we proceed to the application of double integral. So we have the center of mass and moments of inertia. So we first discuss what is lamina. A lamina is a flat sheet or plate that is so thin as to be considered two-dimensional. Think of it as a leaf. Okay, a leaf, you cannot say that it is two-dimensional, but you cannot say also that it is three-dimensional. It is in between, I think, because if you're looking for a leaf, you can see that there is a thickness but very thin. So that is a lamina. It is between two-dimensional and three-dimensional. Okay, so we can get the volume of that one, or the center of mass and inertia, using double integral. If the lamina has a mass density of P, or function of Pxy at any point in the xy plane, then the mass of the plate is that one. The double integral of the function P and then dA. So moments of mass. The tendency for the lamina to rotate about an axis. That is the moments of mass. It is the tendency for the lamina to rotate about an axis. If the lamina tend to rotate about x-axis, we have the formula, the double integral of y times the function of p dA. And then if the lamina tends to rotate on the y-axis, then we have here our formula, the double integral of x times the function p dA, okay, or p of x y. Center of mass. If you're going to talk about center, it is always the average. We discuss in the statistics that the average, the symbol of average is simply x bar or y bar. Okay, so to get for the average in x coordinate, you're going to divide m sub y all over m, and for the y coordinate, it will be m sub x all over m. And the center of mass is, we have x bar and y bar. So let's have an example. Find the center of mass and moments of inertia for a lamina with a mass density of P of xy, which is equal to y, and occupying the region with points 0, 0, 3, 0, 3, 2, and 0, 2. So the first step in here is to plot the different points for you to know the value of x and the different values of x and y. So we have here 0, 0, sorry, we have here 0, 0, next part is 3, 0, we have here 3, 0, and 3, 2, and 0, 2. So what will be the different values of x? So we have 0 and 3. How about the values of y? We have 0 and 2. Okay, so that's the first step. You need to plot the different points for you to identify the different values of x. So we have here the different formulas that I discussed a while back. So we now proceed to solving. We need to get first the mass. So m is equal to the integral of p of x and y, which is equal to y. It is here in our problem. P of x and y is equal to y. Therefore, the integral of y dx dy. So since we start with dx, the values of x are 0 and 3, and then y, which is 0 and 2. So first, we need to integrate the following in terms of x. So that is equal to the integral of 3 the integral of y, sorry, dx, which is x is equal to 3 and 0. So we need to get the antiderivative of y in terms of x, and that is equal to x y. Next is, which we are going to substitute the different values of x, which is 3 and 0. So that will become 3y minus 0y, or simply 3y. After that one, we're going to substitute 3y on our equation, which is that is equal to the integral of 3y dy, and the values of y are 0 and 2. So that is equal to, we need to get the antiderivative of 3y. So in terms of y, so that is equal to 3y squared all over 2, and then substitute the different values of y. So 3 times 2 squared all over 2 minus, if you're going to substitute 0 into our equation, it is equal to 0. Okay, so that is equal to 3 times 2 squared. 2 squared is 4 times 3 is 12. So 12 over 2, or simply 6. That is our mass. That is our first step. After that one, we're going to get the values of f of x. Okay? For a while. We'll just extend this one. Next one is, we're going to get for the value of m of x. So that is equal to, our formula is this one. The integral of, double integral of y times p. What is our p? That is y. So y times y dx dy. So what are the values of x again? We have 0, 3, and the values of y are 0, 2. What is y squared? Y times y. That is simply y squared. So we can rewrite our equation into the double integral of y squared. Okay, so we're going to integrate first in terms of x. So that is equal to integral of y squared dx. The integral of the antiderivative of y squared in terms of dx is equal to xy squared, and then the values of x are 3 and 0. So we're going to substitute the values of x, that is equal to 3y squared. Again, if you're going to substitute 0 into our equation, that is simply 0. So our answer is 3y squared. We're going to substitute it again into our main equation. So that is equal to the integral of 3y squared dy. So we need to get the antiderivative of 3y squared in terms of y. That is 3y raised to 3 all over 3, or simply y raised to 3. Then the values of y are 2 and 0. So that is equal to 2 raised to 3 minus 0 is equal to 8. Next one is m of y. We're going to get for the value of m of y. Okay, for a while. So the formula, we have the double integral of x times p. What is our p again? It is y. So the double integral of x times y dx dy. The values of dx of x is 0 and 3. The values of y are 2 and 0 and 2. So we're going to get the antiderivative of this one first. So it is equal to the integral of 3, 0, x, y, dx. We're going to get the antiderivative of xy in terms of x, that is equal to x squared y all over 2. The values of x are 3 and 0. Okay, so we're going to substitute, that is 3 squared y all over 2 minus 0. Where did we get 0? If we're going to substitute 0 onto the following equation, the answer is 0. So that is simply 9y all over 2. So we're going to substitute 9y all over 2 into our equation. So that is equal to the integral of 9y over 2 dy. We need to get the antiderivative of this one in terms of y. That is y squared all over 4. The values of y are 2 and 0. So 9 times 2 raised to 2 all over 4 minus 0. The answer is 9. So we get already the different values that we need. The mass is 6. The mass when the lamina tends to rotate on the x-axis is 8. The mass of the lamina, if it tends to rotate on the y-axis, is 9. Okay, so we summarize the different answers that we got. We have the mass, which is equal to 6 m sub x is equal to 8, and m sub y is equal to 9. These following values are the things that we need to use to get for the center of mass. The formula is we need to get first the average or the x bar, the average of x-axis and x coordinate and y coordinate. So that will become x bar is equal to, by the way, here's the formula. For x coordinate, we have m sub y all over m, and then y coordinate, we have m sub x all over m. Okay, so m sub y all over m, so that will become 9 over 6. We are going to simplify. They are both divisible by 3, so that is all equal to 3 over 2. Next, we have x coordinate, that is equal to m sub x all over m, which is 8 over 6. Oops. They are both divisible by 2, that is equal to 4 over 3. Therefore, the center of mass is equal to, we have 3 over 2 and 4 over 3. That is the center of mass. So moments of inertia. What is moments of inertia? This is how hard it is to get the lamina moving around an axis. It's all about movement. So if we have larger number or larger lamina, then it is harder to move. So we have here the following formula. I sub x is equal to the moment of inertia about x. So it is equal to the double integral of y squared times p of xy dA. And then I sub y is equal to moment of inertia about y. And the formula is double integral of x squared times p of xy dA. And then I sub o or I sub 0 is the moment of inertia about origin. And it is the combination of I sub x plus I sub y. Okay, so we are now going to get the moments of inertia for this example. So we have the following formulas. I sub x stands for moment of inertia about x. I sub y stands for moment of inertia about y. And I sub 0 stands for moment of inertia about origin. So first we are going to get for the moment of inertia about x. So also I sub x is equal to the double integral of y squared times p. What is our p again? It is y. And then dx dy. The values of x are 0 and 3. The values of y are 0 and 2. Y squared times y is simply y raised to 3. Okay. So dx dy. So we need to get the antiderivative of this one first. That is equal to the double integral of y raised to 3 dx. We're going to get the antiderivative of y raised to 3 in terms of dx or x. So that is simply xy raised to 3. The values of x are 3 and 0. So we need to substitute the different values. So 3 y raised to 3, substitute 0 in this equation, it will become 0. So our answer is 3y raised to 3. We're going to substitute 3y raised to 3 in our equation. So the integral of 3y raised to 3 dy. We are going to get the antiderivative of 3y raised to 3 in terms of y. That is equal to 3y raised to 4 all over 4. The values of y are, we have 2 and 0. Substituting the different values of y, it will give us 3 times 2 raised to 4 all over 4 minus, if you're going to substitute 0 in that equation, it will become 0. So 2 raised to 4 is 16. 16 divided by 4 is 4 times 3 is equal to 12. So we have the value of moment of inertia about x is equal to 12. Next part is to get for the value if our inertia is on y. Okay, for a while, I'm just going to extend our whiteboard. Okay, so I sub y is equal to, we have the formula, the double integral of x raised to 2 times p. So double integral of x raised to 2 times p, which is equal to y, and then dx dy. The values of x are 0 and 3. The values of y are 0 and 2. So that is equal to, what is x squared times y? It's x squared times y. So x squared y dx dy. You start integrating the inner part first. So the integral of x raised to 2y times dy. We're going to get the antiderivative of this one in terms of dx. Sorry, dx dapat yun. So it will become x raised to 3y all over 3. And then the values of x are 3 and 0. Substituting the following values, we have 3 raised to 3 y all over 3 minus 0. 3 raised to 3 is 27 y all over 3. So 27 over 3 is 9. And then y. So we're going to substitute 9y into our equation. So the integral of 9y dy. We're going to get the antiderivative of 9y, which is 9y squared all over 2. The values of y are 2 and 0. So it will become 9 times 2 raised to 2 all over 2. 2 raised to 2 is equal to 4. 9 times 4 is 36 divided by 2 is 18. We already got the values of I sub x and then I sub y. Therefore, we can now get the value of I sub 0, which is, you just add I sub x and I sub y. So that is equal to 12 plus 18. The answer is 30. That's it.